Welcome everyone. First and foremost, thank you Adam for the years. Okay, I've been making use of this to write down the answers. Right, so we will be going through the SA1 paper that you had earlier, paper 2. Okay, I'll be going through question by question. Every video is one question, so it will be easier for you to locate the question that you want to listen to and then learn from your mistakes. Right, so we'll do question 1 for this video. Okay, firstly, you have your papers, but I'll just read off the question, okay, in case you can't remember. So basically question 1 is 2 parts. One is on the Eiffel Tower, then the other one is on the visitors. Alright, so first part is a ball is dropped from the top of the Eiffel Tower 324 meters from the ground. The ball falls a distance of 4.9 meters during the first second, 14.7 for the next second, and then 24.5 during the third second, and so on. The distance that the ball falls each second forms an arithmetic sequence. Right? Okay, so before we go on to the question per se, what we need to do is we need to write down the information given. So what you're given is actually the term, the first term, second term, and third term. So it's good to write down what we are. So I'll be writing it down here. So the first term U1 is 4.9, which is the first second. Okay, and then U2 is 14.7, and then U3 is 24.5. Right? Okay. Then we read the question. The first one they say is find D, the common difference of the sequence. Okay. So there's many ways to do it. You can either take U3 minus U2, okay, or you can take U2 minus U1. I think most of you will do that. U2 minus U1. Or if you are courageous, then do U3 minus U1, and then you divide by 2 is the same answer. Right? So I'll do the first one, A part 1. Find D, right? I'll just use the U2 minus U1, which is 14.7 minus 4.9, which is 9.8. Okay, so that's the common difference. Okay. The next question they ask for 1A part 2 is find U5, right? The fifth term of the sequence. Okay, so all you have to do for U5, if you remember the formula, is equals to U1 plus n minus 1d. So you just, if you are comfortable already, plus 4d. Okay, it's n minus 1d. Right? Okay, so that means this one is going to be 4.9 plus 4 times of your 9.8. Okay, which we arrive at the answer of 44.1 meters. Okay, rather straightforward question. If you know your formula, everything will be quite simple. Okay, the next one, part B, is find S6, the sum of the first 6 terms of the sequence. So you need to remember your formula, S6 or Sn. Okay, Sn is actually n over 2 bracket 2 U1 then plus n minus 1d. Okay, or you can use the Sn is equal to n over 2 and then bracket first term plus last term. But in this case, we do not have the last term. Okay, we do not have U6. Okay, they didn't ask us to calculate U6, so you can't use the first term and last term formula. You need to use the 2 times of the first terms, then plus n minus 1d, and then after that, the whole thing times n minus 2. Okay, so I'll do that. So it's n minus, the whole thing times n over 2. Okay, so 6 over 2. Okay, first term, sorry, 2 times of the first term, 2 times of the first term, plus n minus 1d. So n minus 1d is 5d. Okay, alright, so that will give us an answer of, okay, once you plug in all the numbers, 176.4 meters. Okay, so that's 1B is done. Okay, now 1C. Find the time the ball will take to reach the ground. Give your answers in seconds correct to 1 decimal place. Okay, so for this case, they want the answers to 1 decimal place. So you can't make use of the table because usually table we have our answers to integers. You can make it to 1 decimal place, but it will be a bit of a hassle. Okay, so you need to use the GDC to actually graph it out. Okay, so when you use your GDC, so using your GDC, okay, you need to graph out these two. Y1 will be your SN formula. This one, okay, you write down, instead of 6, right, you write down x over 2, okay, bracket 2 times of your this term, that is, so it's actually 4.9. So 2 times of 4.9 plus, then this one n minus 1d, so you write down x minus 1, and then the d, right, you put in the d we found earlier, 4.9. Okay, so let me write it down. So your y1 is supposed to be written as x over 2 bracket, we have your 2 times of your 4.9. Okay, if you want to write 9.8 straight away, so also okay. Okay, then plus n minus 1 is x minus 1 times your 9.8, because that's your d over here. Okay, so this alone is the sum of the distance. Okay, and then your y2, you put it as 324 because that's the height of the Eiffel Tower. Okay, so what we are trying to do is we want to find where does these two graphs coincide or intersect. Okay, so you use your intersect function. Okay, and then you should be getting your intersect to be 8.13. So since they want 1 decimal place, so I just write it as 8.1 seconds. Right? Okay, for the last part for this sequence, right, they ask find the distance the ball travels from the start of the 10th second to the end of the 15th second. So if you know your concept, this is actually S15, the total 15 seconds, minus S10, the first 10 seconds. Alright, so because you already plot this out, right, okay, this is your Sn. Okay, so you're actually supposed to use the table, okay, using GDC. Okay, you need to write down the table and draw the table. Okay, then calculate what is S15 minus S10. Okay, so locate S15 on your table and then locate S10 on your table, then subtract. So I'm not going to write it down, but it's 1102.5, that's S15, and then 490, that's S10. You subtract those numbers accordingly, you will get 612.5 meters. Right, so you can take a look. Okay, those are the answers. I'm pausing the video here because the next part is a bit different, so I'll continue the next part later. Right, Assalamualaikum. Okay, so this is the second half of question 1. It is still question 1. So the Eiffel Tower in Paris, France, was opened in 1889, and 1.9 million visitors ascended it during the first year. And then after that, the number of people who visited the tower the following year, 1890, was 6.9 million. So in 1 year, there's an increase. Okay, so calculate the percentage increase in the number of visitors from 1889 to 1890. Give your answers correct to 1 decimal place. Okay, so again, it's good to write down the information that you have. So for 1889, which is actually 1.9 million, so 1889, okay, corresponds to 1.9 million. So you can just write down 1.9 because everything is measured in millions. So whatever number you get, you just add on the millions at the back. Okay, so 1890, it was 6.9 million. Okay, so you want to find the percentage increase, it will be 6.9 minus 1.9, and then over the original, which is actually 1.9. Okay, because this is the original number that we started off with. So 1.9 should be at the denominator, and then times 100%, you should be getting 263.2%. Right, so the first one is rather straightforward. Okay, now moving on to the second one, part F. They say use your answer in part E to estimate the number of visitors in 2022, assuming the number of visitors continues to increase at the same percentage rate. Okay, so you notice that this is the percentage increase if you count how much it increases. Okay, this is actually a question of geometric sequence where it increases a certain percentage. Right, so you need to take care of something. If you were to play around with the numbers, right, if you start off with 1.9, you times by this percentage, right? Okay, it won't give you 6.9, it will give you 5. Okay, the difference. Okay, so this is the difference. Okay, so if you want to find the next number, you should be multiplied by 363%. Okay, or in the number form, it will be 3.63. Okay, only if you take 1.9 times 3.632, then you will get back your 6.9. So that idea you need to be careful of, because you cannot write down 2.632. Okay, you write that, that's only the difference, not the number that you're going to arrive at. Okay, so basically what's going to happen is after it's 6.9 is another 3.63, another 3.63, another 3.63. That's why it's a geometric sequence. Okay, so first step what you need to do is you need to find out the number of years that has passed since 1889 to this already 2022. So you get 2022 minus 189, you're supposed to get 133 years. Okay, so take note, if you want to get 6.9, that's 1 year later, you times by 2.63 once to the power 1. If the next number, you will be to the power 2. So the number of years coincide with the power, so you need to raise it to the power 133. Alright, so you will get the visitors right here, 2022 is equal to 1.9 million times your 3.632 to the power of 133. Okay, this will give you an answer of 5.99 times 10 to the power 74. You can write it as 6 times 10 to the power 74 is fine. Okay, you round it up. Right, so the last part they ask is comment on your answer for part F. Okay, so this number is way more than the population of the Earth, because population of the Earth is billions. Billions is actually 10 to the power 9. 10 to the power 6 is billions, 10 to the power 9 is billions. So it is way more than 10 to the power 9. Okay, so you don't really need to see this, you just see the power. Okay, so therefore, for part G, right, okay, this is part F, hold on, this is part E, and then this is part F. So for part G, here. So for part G it is not reasonable. Okay, as the number or the figure, okay, is more than the population, or is more than the world population, okay, of the world. Right? Okay, so we have finished up question 1. I'll be recording question 2 later on. Assalamualaikum.